Welcome back, guys, to the problem solving section. In this section we are going to have some problems to solve from the presentation subjects, which the main of them was dimensions, dimensional homogeneity, and units. For the first question, we are going to solve question number 1.3 from this subject I talked about. The question wants us to solve three parts. Part A, I'm looking to the text I have provided. The product of force times acceleration. So, at the first step, we are going to have force multiplied by acceleration, which is F multiplied by meter per square to power 2. This is also M multiplied by A, which is MLT to power minus 2, as I told you in the text, handwriting. ML to power minus 2. This is also LT to power minus 2. So, multiplication of these, we're going to have ML to power 2, T to power minus 4. Let me explain again. We have a force here multiplied by acceleration, which its unit is meter per square second. Force has also the multiplication of mass multiplied by acceleration, which is which reaches to m multiplied by L to power minus 2 as a unit conversion. So if we multiply these units, L to power minus 2 multiplied by LT to power minus 2, we're going to have ML to power 2, T to power minus 4 here. So, for the second part of this question, let me just erase it. For the second part, we are going to have the some mathematical operations for point B, force multiplied by velocity divided by area. This is united as square meters. This is F and this is m per second. A meter per second for velocity, F for force, area, square meter. This is L to power 2. This is L multiplied by T. Or L to power minus 1. This is also MLT to power minus 2 from multiplication of M multiplied by A. MLT to power minus 2 multiplied by LT to power minus 1 divided by L2. We can have, let me just bring it up. The texts are on the way, guys. M to power T minus 3, because this L2 is going to be omitted, and we are just going to have MT to power minus 3. Let me just explain it again. We're going to have some mathematical operation for force multiplied by velocity divided by area. area has a unit of square meter, force F, and velocity meter per second. Area is L to power 2, F is mLt to power minus 2 because of multiplication of m multiplied by acceleration, and the velocity is Lt to power minus 1. Multiplication of them and solving the mathematical operations, we're going to have mt to power minus mt to power minus t. This was the second part of first question. So, for momentum divided by volume, momentum divided by volume is it is a cubic meter, and a momentum is mass multiplied by velocity, which is meter per second, m, which is big M, Lt to power minus 1. This is L to power 3. So, multiplication of them, we're going to have mL to power minus 2, T to power minus 1. Yeah. So, if you have anything to do with this question, you can have your questions in the caption, or ask your question with the paths I'm going to provide you at the end of the video. See you in the next question. Welcome guys to the second question. The question number is 1.17. We have 5 parts for unit conversions, which is one of the most important subjects in this presentation. The first is ACRE, Acer. 160 Acer is going to be unit converted to square meters. If you have been through chemistry, in there was a subject named as stoichiometry. We're going to use the stoichiometry relations here either. 160 ACRs multiplied by each ACRE is 4.356 multiplied by 10 to power 4 square feet. And each square feet is equal to 9.29 multiplied by 10 to power minus 2. Yeah. Multiplication of this, we're going to have 6.47 multiplied by 10 to power 5 square meters. This was the first section. Let me just erase it for you to get, in order to not get disturbed with the rest. The second one, excuse me, is the unit conversion of gallons to cubic meter. We are going to have, excuse me, this was written badly. 15 gallons according to a stoichiometric relation. Each gallon is 3.785 liters. You can have these unit conversions at the end of the book, which I have provided in the Telegram channel. 3.785 liters, and each liter is 10 to power minus 3 cubic meter. Multiplication of these, we're going to have 56.8 multiplied by 10 to power minus 2 cubic meter. Cubic meters. So, we just solved the second part. Let's go for the third part. You know, unit conversion in fluid mechanics, as I told you in the presentation, is really important. You just have to learn it very sufficiently and correctly. So, we're going to have a unit conversion of miles to meters. We have 240 miles. Each mile is is 5,280 feet, and each feet is 3.048 multiplied by 10 to power minus 1 meters. So the multiplication of the whole, we're going to have 3.86 multiplied by 10 to power 5 meters. This was the third part. So let's go for the fourth part. Let me just bring that up. Yeah. The fourth unit conversion is related to power, horsepower. Horsepower to watt, which is joule per second. We have 79.1 horsepower, and each horsepower is 550 feet pound per second. Excuse me. I just made a mistake. And each feet pound is 1.356 joules. You know, so multiplication of the whole, because this is going to be omitted with this and this is going to be omitted with this. We just have joules per second. The multiplication of the whole, we have 5.90 multiplied by 10 to power 4 joules per second, which is watt. So let's go for the last part of this question, the fifth part, which is a unit conversion of temperature. We have a unit conversion of the Fahrenheit, degree of Fahrenheit, to Kelvin, degree of Kelvin. The degree of centigrade is equal to 5 divided by 9, degree of Fahrenheit minus 32. We have 60.3 degree of Fahrenheit, which if we embed it in this relation, we're going to have 15.7 degree of Celsius. If we have a degree of Celsius combination of 273.15, we're going to have the degree of Kelvin, which is 289 degree of Kelvin roughly, because we have underestimated this part. So this was the second question I solved for you. I hope you have been through it correctly and easily. If you have any questions, you can have your questions in the caption, or ask your questions in the sites or ways I'm going to provide you. Guys, this is the end of this section. I hope you have learned these subjects of fluid mechanics easily and sufficiently. See you in the next section.